Hello, for this interactive advanced concept, I attempted to create ferrofluid. By creating ferrofluid, I took my vegetable oil and I had 2 tablespoons of it and I poured it into the cup along with my jet toner or my black ink toner, and I stirred them around for a couple minutes and tried to get it really like a thin grab my thing, stirred it around for a little bit to try to get a thin consistency between them, because in the video it said that it would not work if it was too thick. So if I stir them around, and I tried it a couple times and was not seeing it, but let me see if I can try this. So if I have my ferrofluid and I put the earth metal to the cup, I'm seeing it stick a little bit, but not much. I don't know how much I can show you guys, but my ferrofluid is not really working out as much as I thought it would work out, or as much as it formed in the video, as it looked in the video. But it's forming a little bit and definitely reacting to the metal, but just not like fully, like really creating the spikes or really doing what it's supposed to do. But if I tried like stirring it around a little bit, I tried it a couple times and it really was not working. So I don't know if there's a couple of things that I wasn't doing right, or they said that if the consistency wasn't like thin enough, it wouldn't work. But I mean, I mixed it around enough, so maybe my metal wasn't strong enough. But here you have my black ink and my vegetable oil with my metal. And yeah, it's really sticking just a tad, but not as much. So as you can see, I just tried to create ferrofluid, but it didn't really work out as much as I hoped. Ferrofluid, I learned, has been around since the 1960s, and ferrofluid is ferromagnetic particles suspended in a carrier fluid with the aid of a surfactant. Ferrofluid can be made with 3 materials, such as I showed the 50 milliliter of my ink toner, and the 2 tablespoons of vegetable oil, and my rare earth metal I have here. So before I poured the jet toner first, and then I added the vegetable oil, and then until I got like a thin consistency, I kept mixing it. But I had to move the cups around a little bit just to make sure I had the right amount, because my ink toner was giving me some trouble getting the ink out of the bottle. So it was a little tricky moving the cups. So maybe that's why it didn't really work. But so I moved them into the small cup here. And then as you can see, I just tried to test it. But the test was supposed to be like take the middle to the cup, and then from there you're supposed to see the liquid magnetize, and you're supposed to see little needles that pop out on top. But that really did not occur, so definitely I think something that I didn't really go as planned. But ferrofluid, it's supposed to work because it's a liquid that contains tiny magnetic particles, and its magnetic properties come from the magnetized iron oxide it contains. And these particles are known as nanoparticles because of their small size, like they're really tiny. The particles are actually so small that they never fully settle to the bottom of their container. And I also learned that ferrofluids are quite special in the world of magnets. Because of their size, the particles turn ferromagnetic magnetite into a super paramagnetic material, meaning they don't stay magnetized when removed from a magnetic field. So the earth magnet can influence the shape of the ferrofluid. I'm guessing how strong the metal is made of or how thick it is might make it stick more or influence the shape. Maybe the spikes would form more. And through these tiny magnets, though these tiny magnets would normally run into each other and stick, Due to increased surface area in the liquid, this is negated and doesn't allow the magnetite to bunch up and lose its innate properties. So once a surfactant is bonded to the nanoparticle, it is considered a ligand. And the ligand is also an attraction to the carrier fluid and kind of pulls the carrier fluid with the nanoparticles as they feel the magnetic force act upon them. A ligand is a molecular anion that can form coordinate bonds to a metal to form a coordination complex. Something that I did not know, ferrofluid seals are used in high-speed computer disk drives to eliminate harmful dust particles or other impurities that can cause the data reading heads to crash to the disk. And ferrofluids have also been proposed for magnetic drug targeting. So in this process, the drugs would be attached to or enclosed with a ferrofluid and could be targeted and selectively released using magnetic fields, which was interesting. And another cool thing I found out is that the application of ferrofluids is used in improving the performance of loudspeakers, or it could also be used in mechanical engineering. Along with using the vegetable oil and the ink toner, there are some other ways to make ferrofluid on your own, such as recycling audio cassettes, and you could also create ferric chloride, which that's cool. There's more than a couple ways to, do it yourself or make the ferrofluid on your own. Some ferrofluids are so attracted to magnetic fields that they will stand up along magnetic field lines, forming an array of spikes. Some reasons why this wouldn't have worked, or why my thing didn't work, could be the consistency of the jet toner and the vegetable oil was too thick. Also, if the magnet you have isn't strong enough to create the ferrofluid, I'm not sure. I mean, I got the magnet on Amazon, and it seemed like it would work good, but maybe it just wasn't a strong enough magnet that'll create the spikes or cause the ferrofluid to be attracted to the magnet. So this interactive advanced concept was really interesting to try out because it wasn't that hard to set up or get the ingredients, meaning because you only needed 3 ingredients to create ferrofluid, which I found interesting. To create something like that, you only needed a couple ingredients. But what I found most interesting was that ferrofluid can be used for so many things. And it will be exciting to see what scientists can figure out how ferrofluids can be improved to be used in certain ways. The only bad thing about this interactive advanced concept was that it was a little messy with ink toner, but other than that, it wasn't hard to set up. I wish that mine would have actually worked or the spikes would have been formed, because I think that would have been really cool to see, and to see it being magnetized to the metal. But yeah, so that's it on today, creating ferrofluid.